Okay, my friends, I am going to make some statements here that CERN is trying to take credit for Rod Warren's discovery, which Rod and I worked together, and his discovery that we could put light pulsed red laser through a venturi using light instead of protons. Light are photons. CERN is using head-to-head, head-on collisions causing just debris. And they had spent 10 years with 400 guys looking through this debris to try to find the particles we have, and we can see them in absolute detail because we're not just digging through debris. And in addition, theirs are just going flying everywhere. Ours are just squirting out like a hose. All right, let me explain to you what CERN is doing. They're taking a lot of protons, zillions of them, and hitting them head on. Now, they think there's things that are glued onto these. They call them gluons. And when they bang them, sometimes they go flying off. And then they look and they see what happened to that gluon, because it was part of this proton. What did it do? Let's see what it did. First of all, when they collide, what do you think happens? They actually snap like that and they hit and you hear them bang like that? No, they don't. Their fields concuss. And the fields are what throw off these particles. And those particles are only because this is not one big chunk, it is 1,839 little chunks, which are dipoles. And then they come flying off, and there's one side is white and one side is black. The black one is the one that they end up calling this dead cone, and it's real heavy. These are little bitty ones. They go bzzz, and they create the Higgs fields. This one doesn't create a Higgs field. It reforms into the Higgs field to create light again. All right, I want you to look at this extremely carefully. This is what they call that gluon. Well, it is really a photon, but it's when the photon starts to decay, and I'll show you that. Then what happens? It starts to give off all these white showers, these little tiny white showers, and the dead particle just keeps going, and then it ends up at the end. It is the only thing that left is that big black particle, and they're showing it as blue. It's black and it has a tiny little border around it. Yes, I agree with that entirely. And it is literally all the weight of all these little things given off are nothing more than heat. And that is basically what they're saying. Now, because they are hitting head on, they're just sort of going flying, and sometimes they spin this way. They can't tell where they're going to end up going. We can, because we can squirt them exactly at a target. So we should be able to weigh them much easier than they can. Okay, this is from 2013. This is Don Lincoln. He posted this saying that there was a fixed particle and a point particle. Let's just cut right down to the chase. At the bottom he says, in summary, the extended particles have a fixed size, that's the black one, although they may have a fuzzy edge around them, which is they do. Point-like particles are mathematical abstractions with zero size. Well, I can't dispute that 100%. But even the zero size particles have an extended effect because of their magnetic field surrounding them. So yes, Don, I agree with that 100%. So when we found these particles back, I think it was 2014, 2015 it was all done, and this is when I did all the videos showing the particles, showing them separate, showing them fuse back together, showing the Higgs fields, showing everything. And these are Don's particles, these are mine. Now, what am I showing? These are photons. Photons are made of two electrons. That's an electron, that's an electron. We never knew about the dark side. We always thought they were just glowy, burny little electron negative charges. No, they have a dipole nature. So every particle there is a dipole. And my theory says that every atom that exists, or every proton, let's just go with protons, exists of 1,839 of these little dipoles. And they would look precisely like this if you were looking at it instead of that as a proton. The outside is the glowy part, and they push the black stuff on the inside. The black stuff doesn't mind being on top of each other, couldn't care less. The white stuff says, get the hell away from me. They will never get any closer than a certain distance. I think it's called the Kashmir effect. So don't forget, I sent this to literally everybody. And I went to the University of Geneva through Coursera to present this to the professors and everything. And they said, wow, this is amazing. We'll follow you online. I said, you're kidding me. What, can you do something with this? And that was the last I heard from them. Everybody else just blocked me. CERN, Fermi Lab, I'm blocked now from everyone. Nobody will respond. And nobody has responded except Don Lincoln, who did this. And told me that I was wrong. None of this is correct. And I said, well, what did you do? What were you showing? Didn't you see what you said for yourself? And then he blocked me. All right, so let's look at this one more time, and then I'm going to show you exactly how we got all this stuff. This is Don Lincoln's claim, and I agree with him 100%. That's the black one with the little fuzzy thing around it. I mean, there it is. There's no difference whatsoever. And there's the glowy little bugger. There it is. And together they make a photon because we were running with a red laser. That's all we had. We didn't have protons. So we can't deal with any of these big chunks that they're looking at. They're looking at things what they call particle zoo. And yes, because when they hit head-on two or more gigantic particles, they get a splash of everything. So instead of seeing one, we started with one. So what can we do? We can only break one apart. And that's what we did. They're starting with this, and now they get gobs there all over, and it takes them 10 years with 400 guys to dig through it to find these particles. We're squirting them out here all day long. And you should be able to pick up everything right on the other side, because we can see the Higgs fields and all that stuff is right on the other side. I'm going to show you all this stuff. And this is where you get the fission from the muon and the neutron, muon and the electron neutrino. They were stuck together, now they're broken apart. That is fission. No other way to describe it. We see in the showers that they're predicting and now claim they have seen. We've already seen them long ago. And we've seen them come back together because we can see these things happen. They can't see that. Once theirs breaks apart and it just goes off into Never Never Land, they're done. They have no idea what happens after that. We can see what happens. They come back together. This is also Fermi Lab, Don Lincoln again, same thing, 2013. I approached him about this. I said, don't you realize you wrote an article about quantum foam? It means that the space is filled with particles, which it says space is not empty. Let's cut to the chase again. Quantum foam is real. The microcosm is in continual motion. Right? The universe is not only stranger than we imagine, it is stranger than we can imagine. Well, I can show you what it is, so we don't have to imagine it, Don. And you're right, it is a quantum foam because light is particles. They don't just go nowhere, they're everywhere. They're all throughout space everywhere. We're plowing through them. That is what we're scrubbing through. And that I had another argument with Don about that. He said, no, that's just crazy. That's just all nonsense. Well, I don't think so. All right, this is really very, very simple to do this. This is nothing more than a red pulse construction laser. Just you buy it off the shelf, 20 bucks, whatever it is. Boom, 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 boom. Every one of these is a pulse. That's how they measure distances, by how they pick up the bounce back. Now, we don't care about that. All we wanted was a pulse. We've got it. This is light coming through. Right here is the leading tip of the wave, which is caused by a particle. There's a particle in here. And right now, its magnetic field around it is creating a wave. And what is all these little dots all over the place? Those are other gases that are in the air that have extra electrons attached to them. You say, ooh, why do they have extra electrons? The extra electrons are heat. Electrons, that's all they are, is heat. They make everything, and they make atoms, and they make molecules, and they make rocks, and they make steel, and they make everything else. But they are also free-floating through virtually everything. That's why you can't get to absolute zero. Absolute zero means no extra electrons, none, zero. That means superconductivity. What does that mean? That means when you put an electron in, it says, there it goes, take every one you can give me. And for an instant, it will take every single electron you can put in there because there's none in there. They want to zip, and then it fills up like a capacitor. And so, whoa, slow down. And that's when you get resistance. Now, the hotter it is, the more of these particles are going to be in the air. Simple as that. And for this magnetic field to push its way through, these are going to be shoved out of the way, and they're trying to shove back. It's push to shove. The pushers are always glowier than the shovers. And all of these guys got to get out of the way for this to get through. Now, what did we do after that? We put a venturi right here. And what is a venturi? A venturi is just a tiny little tunable device that forces all of these waves. You see the wave? That's how big that field is. That's got to compress to get through this slit. It's so tiny that only the white compressible particles can come through. The blacks can't get through. That's why we have this shower. So we didn't hit head on and just see something go flying and squiggling around. We're squirting them, literally squirting them out. And right here, there's a certain distance, and the Higgs fields will start to squirt together, and here they are right here. So from here to here is from here to here. And at this point, they start to spin back into particles. They're no longer separated. All right, now we also did this with blue. Blue's a little hot. It's a little hard to see the blue, but you can see it coming in hot here and slowing down and spinning, and it's coming in almost straight up there, and it's widening out. Just take your time and look at it. Now, here's the particles right here. There's the particles. And those are the particles that split apart right up here, causing fission, and they came back to here, causing fusion. Now, that's something CERN can't see. They have no idea about that, because they're just hitting head on and seeing a bash of, they're seeing all this kind of glow everywhere and particles going everywhere, but that's all they can see. So they know these particles exist, but that's as much as they can determine. We can see them, we know what they're doing, we know how they started, we know how they ended, we know how they split, and I can show them in the process of accelerating and splitting. And not only red, I can show it in green too. Okay, here's what happens. The pulse red laser's coming in. The venturi's here. The only way we can see these particles is because they're accelerating now. Otherwise you don't see them. You don't see them up here. They're there, and they start to show up a little tiny bit way on the edges. But the one right in the middle starts to glow. The first thing you see is this sideways thing. And then they turn into a little box. And then they hit the venturi and they explode and they fall apart. As you saw, they split apart. Now this is the same thing, only the green is hot compared to the red. And I can show you those two at the same time and you'll see the obvious difference. This comes in and then you see this. Now, you see this white looking, like flashy looking up and down instead of being nice white round balls? This is just getting ready to flip. The bottom one is coming, this is the same particle, and because you take it all at one shot and it's going all in one thing, and it gets like, I don't know how many clicks at a time, but a lot. You can see that blue was all one particle, and I showed you. Now this is all one particle. It's charging up now. The bottom is charging up. Remember the red one was coming through the air and you could see him pushing all those little dots in front of it? And I'll show you the red one charging up too. As a matter of fact, I can show you that well too. But this is the first time I've ever seen it really in that much charge state, because now it's going to flip. And then the top one will come to the front and the bottom one will go to the back. And that's called upspin and downspin. But there's the green. You saw the red. Now, don't forget, that's the photon. I've shown that quite well. And then I've shown that it divides quite well. And the black is that fixed particle that Don Lincoln talks about. And the white is the point particle. Now, what is it doing? It's coming forward. You can see this one's glowier than that one. Well, that's because it's hitting those particles. Remember we talked about those little particles? It has to get past them. They are pushing, they are shoving. And it will glow until it glows so much that it flips. And then the top one comes, and then you have an upspin or downspin, whatever flip, because it's called a muon wobble. It's nothing. I'm not making up any of these things. This is not all the terms they use from Fermilab and the rest. Except now they want to change all the names of everything and turn them into partons and all that, because I showed them what to look for, and they wouldn't pay any attention. Now they want to take credit for it. That's the only reason all this stuff is going on. I'm showing you exactly what they're showing. No difference whatsoever. 7 years ago, I presented this to every one of them. See this? I even knew it was dark energy and dark matter. The video, the title of this 7 years ago was Light is Dark Energy While Traveling from the Sun to the Earth. In space, it's loaded with this stuff, completely packed and saturated. All light has to get here somehow, and these particles are light. Now this one here, we pushed all the black particles to this side and only the white particles to this side by offsetting the venturi. Alright, this is what light looks like from the side, zip, going this way. And what it's doing is it's spinning. And the particle is at the tip, spins, zip. And the longer the light wave, the wave looks long. It looks like a wave, but it's a particle. The particle spinning through creates the radiance that you're seeing. And when two particles cross path with each other, they create additional radiance. You see this one's crossing path with that one? Sometimes they're here and there to cross path. And that's because sometimes they go this way, and sometimes they come over this way, and sometimes they go over this way. Because the venturi's back here. Now, let's take another look at that. Now check this out. I believe the venturi is right here. Rod did these, but I believe he put the venturi right here. And what he's seeing is the light is being forced into the venturi and it's crushing together, so it starts to glow, and as it exits the venturi, it splays right out like crazy. As we could see those white showers, only they're showing up red here. Now, what is that? I believe that is the pulse of light from the last pulse. So it's a pulse, pulse, pulse. That's the pulse. This is actually the light particles starting to turn, to spin through that venturi. These are the back side of the particles, I believe. And this is the back end, and that wave is going forward. All right, let's take a little time to look at this. What are we looking at? First of all, you see the wave, which is the particle as at the tip of it, and it's being obviously accelerated. And it's beginning to manifest and glow because it's pushing and shoving. Here, as I showed you before, the black separates from the white, and here it comes back together. These are Higgs fields when they start to come back together. Now, what are we looking at here? Well, we know this one's accelerating. And that's a light wave. Is there any other light waves here? Yeah, they're all over the place. Well, how come we don't see them? They're all over here. They're everywhere. We don't see them. Well, guess where you do see them? Just before the venturi. And why do you see them here and not way back here like this one? Because it's not accelerating. They're not accelerating. You see them? They're just nice and round. This one's accelerating. Well, what happened here? It exploded backwards. That's the only reason you see these. You see how nice and rounded they are? They're not getting accelerated. The only one that's accelerating is this one. These are being pushed back against so violently that they create the same kind of reaction as happened in here. In this area here, it's like, it literally is a subatomic nuclear explosion. All right, it's below the nucleus, but it is a subatomic. That means below the nucleus explosion, and that radiates back here. You see these waves back here? You see those concussive waves? That's called reverse EMF, electromotive force. You see the violence that they're coming back with? That's like being 2 miles away from an atomic bomb and being knocked over by these waves. They are just unbelievably strong coming back. This is an increase in energetic value from where it was back here, virtually unseen, to being off the charts. And I would say, and CERN and the rest of them do say, that should increase it by about 200 times. I don't see any reason that that's not acceptable to understand that. Now, let's take a little bit further look at what we see right at the point of impact, right where the separation of powers is. All right, like I said, I'm a material scientist, and I want to know, what are we absolutely certain of? We're absolutely certain that that was a pulsed red construction laser, and that is the light. We're absolutely certain that something is manifesting itself and turning very bright, and we could see that particle as this particle right here. So we're absolutely certain of that. Now, what else are we absolutely certain? They divided right here. They came apart into little bitty pieces. Not a single taste of them came through the venturi. And then they recombined over here. No question whatsoever. We can see that in extreme detail. So these are the things we're certain of. And we're also certain that that is exactly what CERN says a muon and an electron neutrino should do. The black ball should go on its way and become a sterile muon, and the white one should turn into electron showers. Absolutely no question. That's what happened. That is locked in stone. There is no way to get out of that. So if you could just dismiss that, you got some serious issues. All right, so don't forget, I'm saying right here is where they split. Right here is just raw energy, and right exactly on that spot, see that line right there? That's when they start to form the Higgs fields and become back to their normal light, basically, photons. And at that point, it seems like there's a hell of a lot of heat energy right here. I mean tons. And when they reform to the black, it just turns them back into like a neutral particle of heat. I can't really account for it, but when I see it in an atomic explosion, it's quite obvious. The first thing that happens is the white particles hit, and the buildings just burn up like this. They don't go anywhere, they just burn up. Next thing is the black hits, and phew, everything goes. Nothing burns anymore, just everything goes. So now you've gotten back to semi-normal temperatures. Still going to be extremely hot, obviously, but it's not going to be like that first pulse, which just everything vaporizes, literally vaporizes. All right, see it here, this is Sci News. This is a physicist. The first time directly saw all these chromodynamics. This is exactly the same particle. Theirs just goes flying off into space. Ours comes straight squirting through. Now, here they say physicists from the ALICE collaboration overcame these challenges by applying state-of-the-art analysis techniques to a large sample of proton-proton collisions at the Large Hadron Collider. Proton-proton gives them thousands and thousands and thousands of particles to dig through that have no orientation whatsoever. They're just nothing more than like a head-on crash of two cars that are made out of glass. That's all it is. These techniques can roll the parton shower back, parton, in time from its end products. We're doing that right now. We're starting to watch them come forward. We don't have to go backwards. The signals left in the ALICE detector by a spray of particles known as a jet. Well, I showed you our jets. They used to call them electron showers and muon neutrinos and electron neutrinos. They're changing all the names because Rod Warren and I beat them long ago, and they just dismissed it and trying to take credit for it now by refitting the Large Hadron Collider to focus exactly the way we showed them to focus. And now they're seeing the same particles and saying, oh, we did it. No, you didn't. We did it. Furthermore, they're talking about quark masses. Mass is not just the weight of the particle. Mass is the impact value that it has when it hits something. You could take a golf ball and just bounce it at something, and the mass value of that is just like an ounce. And if you throw it 1,000 miles an hour, it's like half of an atomic bomb. The mass is the impact value, and what they need to do is to see how much impact value it has at different frequencies, which is what we have done. Well, maybe I didn't show you. Hold on. Okay, here's another one that was done. Fabien Boulay, I believe he was over in France. I'm not sure where he is now. I know he travels a lot. He did this one showing both the red and the green at the same time. See how weak the red is? Very, very weak compared to the green. The green is so strong that it turned the red into barrel rolls. I have a closer shot up of this. You see up here? This is the same particle, the black and white. But this is a more pixelated phone. Rod's phone was a Samsung Galaxy S3. From 2012 they came out, and it was just unbelievable. And it's still, he claims it's still his best one to pick these things up. Now, this is a little closer. Look at what happened here to the green pushing against the red. Look at the red. Turned into little circles. Normally, you know that I showed you, this is going to be this way. It would normally come through spinning just like this. just like these are as they come back in again. But this is pushing it and it's making it tumble like this instead of spinning the way it's supposed to. It's tumbling. You can see it. All right, we've got some pretty serious work in this, and to have it dismissed and walked away from it gives me a bad feeling. All right, here's the green, the same thing as the red. The shower, the Higgs fields are starting to be created as these particles slow down and bang back into the atmosphere. All right, let me just quickly go through this one more time. Here's the light pulsing. There it is accelerating. This is where it divided the black and white particles together. Now, here is where the Higgs fields start to be created right here. There's the Higgs fields. They're coming at us. All right, here they are again. Here's what they actually look like. That is actually the Higgs particles. And the dark spot is in the center of the white glowing spot. That's because it's coming forward. The carrier is the black part, apparently. Seems like to me, or the white part is banging into the black part at this point, because that's right here at the tip of the waves. These are the very, very tips. Right at the tip of all these waves. And this is where it comes through the venturi, right here, right that spot. And then there's a distance from here to here before they start to concuss and create the fields. And at that point they start to spin into particles again. Prior to that, the white particle, I don't know what it was. All it was a white shower. You can see it. And then right here is where it starts to come back together. Okay, this is pretty stunning. This is where the Higgs fields start to collect in front of the laser output. So they're starting to concuss with the darker particles that are in the air. So the first concussion, they're glowing like crazy. And as they continue further out, they start to lose some of that energetic value. Now, here is something that was extremely interesting. You see that particle? These all are supposed to be red. You see this disc and this disc and this disc over here? They actually pinched one of these and made it turn blue. I didn't think that was possible. I mean, I'm seeing all kinds of things I never thought were possible. It squirted it out like a tube of toothpaste. You see it crunching right down and making it into a funnel. Now, the other thing you see is, you see these lines, it's hard to, you're going to have a hard time seeing these, but I can see them. There's lines in these are patterns of where these pulses go. Anytime you see a bright pulse, that means that's where you had an impact. And that's what those other pictures were showing, all of those little particles. And you can see right down in the center of them. You see that little bitty center one? There's one right at the tip. They have a tip with all of those six-pack around it. You see how these particles are lined up like this? That's what caused those other patterns that we saw. Hold on, let me see if I can find them. Hold on. See it? That's these here. And as they come forward, they create a spin. You see them, they're all spinning in the same direction. And then we did have one, though, that spun backwards. That one there freaked me out. I'll show you that one. That one, well, this one freaked me out, too. All right, you see that? This is the venturi. You see these little sprits coming out of here? These are when they're just white. And then bang, 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 bang. This one here is going backwards. There's supposed to be a right-hand spin. That one, I think, is gathering the field into itself. And after it concussed with one of these fields, watch what happened. This happened. That one there blew my mind. To me, it appears to be the same particle as these. It has the same characteristics. When it concussed, it appears that this concussion caused it to convert back into whatever these are. And this is whatever that is. I mean, you know, what can I say? Nobody's ever seen this before. Nobody's ever seen any of these things before. So, you know, even CERN, they're so far away from where we are. It's amazing. We're squirting them. Actually, we can focus them right where we want them. and just do this all day long. They're just could have an accidental banging head on and then digging through debris. It's just totally, unbelievably less elegant as what we're doing. This is just fabulous, really. Okay, so, well, it's good that CERN caught up with us after 7 years. You know, we showed it to them, and apparently they wanted to realize were these guys correct or not. You know, they shoved us off into the woods, but they eventually got to the end 7 years later when we could be driving our cars for free for the last 6 years easily. And we could still do it right away. I've shown this over and over and over. Now they're saying, yes, Roger was correct. Yes, these particles exist. Yes, they're extremely energetic. Yes, there's a new heat engine from MIT. We can harvest that heat, which is only heat for an instant, and then it turns back into regular matter again. It's raw heat right here. And if that raw heat can be accumulated, that's atomic fission. And we should be able to drive forever for free. It's non-polluting. It's subatomic, so it's not like if it explodes, it gives off big chunks. It won't do anything. It can't explode. It's elegant. It's cheap. These things are readily available. We could have them working in a couple of weeks. Just got to hit this thing like a SWAT team, get it done. And I'm seeing no interest in this in the dire conditions that we are in with energy right now. The world is falling apart. If we could do anything like this to help, it would change the world literally overnight. And I've been screaming about this for 7 years. That's why I'm a little frustrated, and I probably was a little semi-nasty. But, you know, at some point, what do? You have to stand up and say something. It's very, 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 very upsetting, basically. I got to be honest with you. I'm upset about the way this has been handled. And we could be driving our cars for free right now, and we can in a month. If somebody would just stand up and say, you guys spent billions of our dollars, got nowhere. And now you're saying exactly what Roger's been saying for 7 years, saying we could get free energy. I want this jumped on.